Okay, good evening everyone. So today I will cover the tutorial number 4. Let's start. So question number 1 is just simply find the probability for the standard normal random variable. So here already given the z value which is 2.33. So since below, so no problem, just simply take from the table, we will get 0.9901. And then for the b, also same way of the a, so we will get 0.95053, but only difference is here is 3 decimal places, so the table only can get 2 decimal places, right? So just simply round off, so we will get 1.65. Then so for the C is a bit different. Z value is greater than 1.96. So since greater, so we need to 1 minus the probability below, because the table only can get the below value. So we just simply 1 minus the probability of the below, we will get the above one. So we will get the value 0.025. Okay. Then we go for D. So the D is so between negative 2.58 and also 2.58. So just simply we minus the probability of the 2.58 minus with the probability of negative 2.58. Okay, see, we will minus this both, so we will can cut off this part, so we will get this probability. So the value is 0.99012. So number 2 is find the value of z naught, so such that the probability is given ready. So the probability of given 0.025. Okay, but we only can get the below, right, from the table. So we just simply 1 minus this value, so we will get the probability from the table. So when we minus here, shift over, we will get the probability 0.975. So it's more easy to find the z naught. So z naught from the table is 1.96. Okay, so the place of the z naught 1.96 over the positive part. Okay, positive part, and also the probability and the position of the probability given is this part only, not this part. Okay. So for the B is probability of between negative z naught to z naught, right? So both part also got. So from the probability given, we divide 2. It's more easier. First we 1 minus the probability that given, because we only want the below part, right? So 1 minus 8 and then divided by 2, we will get the probability. Okay, probability, and then so we refer the table. So the table is, don't forget to put the negative z naught, because now we're using the technique of just negative z naught. Okay, just negative z naught. So we just simply 1 minus 8. So when 1 minus 8, we will get the balance part, and then we divided by 2. So this balance part then divided by 2, we will get one part only, right? One part only, because these two are balanced, because equally divided. So when we get one part, then from the probability, the one part of the probability, so we can find the z naught. So don't forget about the negative, so put the negative, so we will get also the value of z naught is negative 1.36. So the z naught is 1.36. Also can use other way. Okay, now we go for number 3. A normal random variable acts as a mean, which is 10, and also standard deviation 2. Okay, so from here we need to standardize. Okay, standardize. So then only we can find the probabilities. So the A is x is greater than 13.5. So we need to standardize. So the standardized formula is x minus mu divided by sigma. So use the same symbol, still use the same symbol, and we need to transfer our random variable data into standardized form. So we need to minus with the mean divided by sigma. We will get z greater than 1.75. Then, so since now only we can transfer this data into z greater than 1.75. So simply 1 minus e so that we can refill the table. So we will get 0.04006. Okay, then B is probability of x less than 8.2. So probability of x less than 8.2. So we need to standardize it. So z is equals to x minus mean divided by sigma, and then is less than, still same symbol, and then 8.2 minus with the mean divided by sigma. Okay, which is 10 divided by 2 minus 10 divided by 2, so we will get negative 0.9, and this one transfer it into z, and also the same symbol. So this one can simply use the table, so we will get 0.18406. Then we go for the C, which is the probability between 9.4 to 10.6. So we need to use the same technique and transfer it into z, and then this one don't forget to minus with mean divided by sigma. So we will get negative 0.3 between z, between the less than negative 0.3 less than z less than the 0.3 positive 0.3. So we will get the probability simply by minusing, so that we can discard the right hand side, which is below 1, below the negative 0.3. So minus it, we will get the between probability, which is 0.23582. Okay. Now we go for the number 4. Okay, number 4, a normal random variable x has an unknown mean and also standard deviation. So the probability x exceeds the 4 is 0.9772. So the x that exceeds the 4 is 0.9772. So we don't know the mean and also the sigma. And also another probability is given which exceeds the 5 is 0.9332. Okay. So we want to calculate the mean and also standard deviation, right? So from these two data given, we want to find the mean and also the standard deviation. So we just use the simultaneous equation. So we transfer it into the z standardized form first. So when transfer it, we will get this one and this one for exceeds 4 and exceeds 5. Then we minus with 1. This one also same. Minus with 1, we will get 0.0668. This one 0.977. Sorry, 0.0228. Okay, we get the both equation ready. So now we can take it out, because from this probability we will get the z value. So here z value is negative 2. Here z value is negative 1.5. So since this one is equals to negative 1.5 and this one equals to negative 2, we can just take it out and make it simultaneous. So when we make it simultaneous, we need to transfer all the data so that there is no denominator, not in fraction form, it's in the equation form. So we transfer it, we will get we transfer this both equation into this form, So we will get these two equations. So we simultaneous it. So we just simply minus it so that we can discard the mean. So we can get the answer for the sigma simply 2, and the mean we calculate back by transferring sigma into 2. So we can use any equation to find the mean. So we will get 8. Now for number 5, suppose that the amount of money spent at shopping center between the 4 to 6 p.m. as a normal distribution with mean 85 cents. So this is the mean and the standard deviation is 10. Okay, so now we want to find the probability lah that has spent more than 90. So the first question, more than 90. So we need to, as normal, need to standardize. We standardize it, we will get x greater than 0.5, and then we just simply transfer it 1 minus less than. So we will get 1 minus this probability, we will get 0.30854. Okay, that's probability that has spent more than 90 cents. If we write in sentence form, it's more clear. Okay, then for B, what is the probability that has spent between 90 to 100 at the mall lah? Okay, so it's in between, in between 90 and also 100. So we need to standardize it. We will get 0.5 to 1.5 lah. So just simply minus the probability, which is minus the probability of 1.5 until 0.5, so that we can get this probability between 1.5 and also 0.5. So minus it, we will get 0.24173. Now C is quite different because there is two shoppers selected, so they want to know the probability that is spent more than 100. So more than 100, first we find the probability that more than 100. So use the same way to standardize it and get the probability 0.06681. So since there are two shoppers spent together, right? So we have to times the answer twice. So 0.06681 and times with the 0.06681. So times the same probability because there are two shoppers. So we will get the probability 0.004464. Since they are shopping together. Okay, both shoppers have spent together more than. So we just simply times lah. Okay, so get this value. Okay, now we go for number